In exercise 3.3, we had a look at the association between numerical and categorical variables. Previously in 3.2, we had a look at two-way tables and compared two categorical variables. Here we're comparing, situations where we would have a numerical data and categorical data in the same collection where we make comparisons. So here, first up, what we have is a back-to-back stem and leaf plot. This here is great for comparing two sets of numerical variables. So just like a two-way table is great for comparing two sets of categorical variables, here a back-to-back stem and leaf is awesome for comparisons of two numerical variables. In the example below, we have Liz and George who deliver pamphlets to letterboxes. The number of pamphlets delivered per hour over 12 hours is shown below. So 32, 24, 27, so on and so forth. In the right leaf, we've got Liz, and we've got our most important thing that people always forget is the key. You're never asked to construct one of these in the exam, but make sure you check the key, because sometimes the key might say 4-5. So if the stem is 4 and the leaf is 5, that might mean 4.5. Okay, so just make sure here we're checking the key. Here 4-5 or 4 stem and a 5 leaf is 45. All right, so if question A says display the data with a back-to-back stem and leaf plot, we've done this in multiple units over the years. You would put Liz's data in the right leaf, George's data in the left. Obviously, it doesn't really matter which way you have it in, but as long as you put them in order from lowest to highest, and you align each numbers column, so then we can sort of see the skew later on, then you have a pretty good stem and leaf plot that's back to back. Otherwise, if you have the order, if you've ordered it correctly and you've had a key or you've interpreted the key, you're on your way. Just make sure you don't read it back to front. So for George, this here isn't 851 or 51. This is 15, 18, 21, 24, 25, 29, so on and so forth. Part B says comment on the shape of the data for each person. So whenever we see shape, all right, we need to think skew. All right, what sort of skew are we talking about? Well, Liz's is approximately symmetrical, whereas George is more negatively skewed. All right, so hopefully you remember back from chapter 1, your skews. If you have difficulties, please review back through those notes. C, calculate the median. So the median range IQR, the median here for Liz, what you would have to do is you would count how many total data points you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What you also notice, one thing I forgot to mention in A is they've split each tens into top half and bottom half, meaning you've got 24, so 20 to 24, 25 to 29, 30 to 34 in this row, and 35 to 39 in this row, and so on and so forth. All right, but that doesn't really change how we calculate the median. You would still count to the middle. For Liz, 29.5 would be your median. So where that would lie is just past the 28 and just before the 31, so right in between. So it's a split. So you would have to add 28 with 31 and divide that out by 2 to get your 29.5. The range is your highest number, take away the lowest number. Your IQR is the median of the top half, take away the median of the bottom half. So once you've got your split here, you've got 31, 32, 31, 32, 32, 32, 35, 35 as your numbers in the top half. So if you count to the middle, you've got 1, 2, 1, 2. It'll be a split right between the two 32s. So that's why we've got this 32 here. The median on the bottom half, you've got 1, 2, 3, 4, 5, 6. So it'll be a split after the number 3. It'll be a split right between 26 and 27. So the average of 26 plus 27 divided by 2 gets you 26.5. And IQR is the Q3 value, take away the Q1 value, which gets us 5.5. And again, if you're unsure of how we got all that, just skip back to chapter 1. George here, the median, we've got 30 with the same working out. Range is 30 as well, because we've got 45 take away 15. The interquartile range is 12.5. So who would you say is the better delivery person and why? You would compare the medians. All right, the medians are about the same. So on average, they drop off about 29, 30 pamphlets each day. But George's range and IQ are considerably higher than Liz's, which means George is quite volatile. Some days he'll deliver heaps. Some days he's not delivering very much. So if you want consistency, Liz is your go-to person because there's less volatility in terms of how much she's delivering each day. But but otherwise, that's all we can tell in terms of who's more consistent. So Liz, if it's based on consistency, would be the better delivery person. Parallel dot plots, another great way to compare two sets of numerical data. So back in chapter 1, we spoke about dot plots. Dot plots literally just tell how many people are in whatever category you're talking about. So for example here, if we're talking about the age of team members in 3 different sporting teams, we've got 1 person in team A, that's 14, 4 people in team A, that's 15, 5 people in team A, that's 16, 3 people in team A, that's 17, so on and so forth, and team B and team C represented above. If we were to describe the shape of the distributions, team A here is pretty much symmetrical. You've got a peak at 16 and then even distributions or close to on either side of 16. Team B appears to be positively skewed, so it's running away from the positive. Most of it, it's loaded towards 0. Team C is roughly symmetrical too, because we've got 3 even peaks with a few people in between. So there's a balance on either side of the peaks. Part B, calculate the median, range, and IQR for each team. What you would have to do is you would have to, for example, team A, we would have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 team members, and you would have to figure out the middle of 15, which is number 8, because if you count, or if you divide it by 2, you get 7.5. When you get a split like 7.5, you just round it up to the next whole number to get your median. So 1, 2, 3, 4, 5, 6, 7. This dot here that I'm hovering over is the median, which is 16. The range is 18 take away 14, which is 4. The interquartile range is going to be the average of the top half. So you've got 1, 2, 3, 4, 5, 6, 7. So 7 numbers on either side of the median. And so the middle number of 7 would be 3.5. So you round that up to 4. So the 4th number is going to be the median from the top half and the bottom half. So 1, 2, 3, 4. This dot here, which is 17, is going to be Q3. 1, 2, 3, 4. This number here is going to be the median of the bottom half, which is Q1. So 17 take away 15 gets you the IQR of 2. You do that 3 more times for teams B and C to get your median, range, and IQR. So, do you agree with the statement, Team A is at a disadvantage when playing the other 2 teams? Justify. Well, you would compare the medians. Team A is significantly younger. They've got the same range as the other 2 teams, but their interquartile range is slightly lower. So what does this mean? The median age for Team A is lower than teams B and C, as we identified. Performance in sport is generally increases with age, especially from the ages of 14 to 20. So a team with a median of 16 may be at a disadvantage playing against older kids, who some of them are 18 in our example. So Team A also has the lowest IQR of the 3 teams. This indicates that the middle 50% of the players are concentrated around the low median, which also suggests that Team A may be at a disadvantage against the other 2 teams. So interquartile range just says your average spread. So the middle 50, not average, your 50% around the median is quite low too. So those 2 things combined, the low median and the lowest IQR spread, causes a disadvantage in a sporting context. Parallel box plots is another great way to represent numerical data. So this sort of stuff you're probably going to see on an exam at the end of the year because of all the, I guess, the 5 figure summary that's included, the IQR, you know, the fences, outliers, all of that sort of stuff can be included in a parallel box plot to represent. So that's why the VCA really like parallel box plots. So make sure we're focusing here. If we're looking at this example here, you can always construct a parallel box plot nice and quickly with a CAS. So here's your steps down below. Add a spreadsheet, type class A in cell A, class B in cell B. Input the respective data in their respective columns. Just don't input it in the grayed out row just below the A and B cells, which we should be used to by now. Press Control Doc button to add a data and stats page where you'll create a parallel box plot. Drag the cursor to the X, click Add Variables, Class A, press Menu 1, 2 to get your box plot, and then press Menu 2, 5, and then select Class B to get your parallel box plot. And then from there, you can drag your cursor to figure out the 5-figure summary if there's any outliers. Now, it's really important after each spreadsheet that you delete it. So for the next question, if there is another parallel box plot, that you don't get the data points confused, which is a common error people often do. So yeah, delete spreadsheets once you're done. Just double check before you delete it that you've did everything right as well. Okay, so common errors are people input it wrong, people use the wrong set of data. But again, the VCAA, it's very unlikely for them to get you to create one because of how tedious it is and time consuming. So they're probably going to give you a question like this, where you're asked to interpret the parallel box plot. So the parallel box plots below represent the average temperature in June for Victoria, New South Wales and Queensland over a number of years. Which state has the highest median? The median is always the middle line in the box. And if we take a look at here, Queensland with an average temperature of 20 is the highest state in terms of temperature in June. Which state has the largest range of average June temperatures? Average range, New South Wales, because you've got 21, take away 0. I want to say that's not quite 0, that's about 0.5. Which is a range of, 20 and a half. All right, Queensland, we're dealing with a range of 31, take like 14 and a half. Okay, so that's not going to beat New South Wales. Victoria's dealing with a range of just above 16. Yeah, again, that range of 15 isn't going to beat the range New South Wales has at 20 and a half roughly. It's really important that you note this down, that The range also includes outliers. So if there was an outlier here, you would go the outlier, take away whatever the lowest is. And if there's another outlier, you would go outlier, take away outlier, or outlier, take away the minimum, or outlier, take away the max, or maximum, take away the outlier, depending on which side the outlier is on. So outliers are included in the range, just so you know, for future reference. Which data is best described as positively skewed? So data that's running away from the positive, so stacking towards zero. You would say Queensland here because majority of their bar is concentrated towards the lower end. So the shorter a whisker is, or a shorter a box is, the more data points are between these numbers. So they've got a cluster of days where they had temperature between, 16.5 to 20 degrees, okay, in June. Part D, which state has the lowest average June temperature? So New South Wales have the absolute minimum. That's why we've got New South Wales there. Write a brief summary comparing average June temperatures for each state. Victoria and New South Wales have similar average June temperatures. As we can see, they're both at around 10 and 11 degrees, whereas Queensland had a higher average June temperature, understandably, because they're closer to the equator than the other two states. So there we've compared the average, which is, again, the center line of the box. Do you think there is association between the states and their average temperatures in June? Provide some evidence for your view. There may be an association between the state and average temperature, as Queensland's data is significantly different from the other two states. The middle 50% of Queensland's data has no overlap at all with the middle 50% of New South Wales or Victoria. At the same time, you can say that Victoria and New South Wales are pretty similar, so there's some sort of association there, but Queensland's is substantially different. But they do all overlap to some degree, so there is that box here between 15 degrees where Queensland is at their minimum, which is close to Victoria's maximum, and New South Wales maximum of 21, which is also in this sphere of association. Okay, so that's all for exercise 3.3. Let me know if you have any questions.